Good morning. My name is Dr. MPVV Bhaskar Rao, Associate Professor, Department of Basic Sciences and Humanities. Now I am going to explain eigenvalues and eigenvectors unit from Mathematics 2. So in Mathematics 2 I am going to explain the chapter Eigenvalues and Eigenvectors. Okay. So it comes under linear algebra, and the main applications of eigenvalues and eigenvectors chapter is it can be used to find rank of Google's page, and it can be used in designing bridges, it can be used in communication systems, and can be used in RLC circuits, and it can also be used in designing car stereo systems, and there are several other applications also, like exploring a land to identify the oil source. So in such areas this unit eigenvalues and eigenvectors will be used. Okay, and these are all applications, and the topics in this chapter are: first one, Cayley-Hamilton theorem. Okay, then eigenvalues and eigenvectors. Okay, Cayley-Hamilton theorem is one topic, eigenvalues and eigenvectors is the other topic. Then quadratic form is one topic, and continuation canonical form is the other topic, and the last topic is conversion of quadratic form into canonical form by using orthogonal reduction. Conversion of quadratic form to canonical form by using orthogonal reduction. It is the last topic. Okay, these four are topics in this unit. The applications of eigenvalues and eigenvectors are: it can be used in designing bridges, it can be used in finding Google's rank page, and it can be used to design car stereo systems, it can be used in communication systems and RLC circuits, and it can be used to identify oil resources while exploring a land. These are the applications of eigenvalues and eigenvectors. Now let us see the topic Cayley-Hamilton theorem. So I want to start Cayley-Hamilton theorem. The main application of this Cayley-Hamilton theorem, this can be used to find inverse of a given square matrix, and it can be used to find the power of a given square matrix. Suppose if a 2 by 2 square matrix is given, you can calculate its inverse using Cayley-Hamilton theorem, and parallelly you can find a cube using Cayley-Hamilton theorem. Okay, so in order to start with Cayley-Hamilton theorem, you need to know certain basic definitions. First definition is characteristic equation. Okay, so in order to start with Cayley-Hamilton theorem, you need to know characteristic equation. Okay, suppose A is a square matrix. Suppose A is a square matrix, it means the number of rows is equals to number of columns. Then A minus lambda I, where A is the square matrix, lambda is the parameter, and I is the identity matrix, same as order of A. Then A minus lambda I is called characteristic matrix. It is called a characteristic matrix. Okay, then finding its determinant, it is called characteristic polynomial. Okay, and equating this determinant to 0, it is called characteristic equation. Okay, if A is the square matrix, then A minus lambda I, where A is the square matrix of order n by n, and I is also identity matrix of order n by n, and lambda is the parameter. A minus lambda I, this matrix is called characteristic matrix, and taking its determinant, it is called a characteristic polynomial, and equating that polynomial to 0, the equation is called characteristic equation. Okay, so that A minus lambda I is equals to 0 is called characteristic equation. Now let us see the statement of Cayley-Hamilton theorem. Statement. The statement says that the statement of Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. Okay, so this is the statement of Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. We know the meaning of square matrix. Square matrix means where the number of rows is equals to number of column, and we already discussed about characteristic equation. Characteristic equation is given by determinant of A minus lambda I is equals to 0. Okay, so let us see what this statement explains. Suppose A is equals to some matrix 1 0 0 1. This is the square matrix of order 2 by 2. Okay, then its characteristic equation can be calculated using the formula determinant of A minus lambda I equals to 0. The characteristic equation will be lambda square minus 2 lambda plus 1 equals to 0. By using the formula determinant of A minus lambda I is equals to 0, we will get lambda square minus 2 lambda plus 1 equals to 0. This theorem explains that whenever you replace lambda by square matrix A, the equation will be satisfied. So it will be A square minus 2A plus 1 into identity matrix is equals to null matrix. Okay, the theorem is explaining that if lambda square minus 2 lambda plus 1 equals to 0 is the characteristic equation corresponding to A, then we can have A square minus 2A plus I is equals to null matrix. That is, this equation will satisfy when you substitute lambda equals to square matrix A. This equation will be satisfied when you replace lambda by A, that is A square minus 2A plus I equals to null matrix. Okay, so Cayley-Hamilton theorem statement is saying that whenever you take a square matrix, that square matrix satisfies its own characteristic equation. So the statement of Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. Okay, now let us see an example problem on Cayley-Hamilton theorem. Suppose if A is the square matrix 1 2 2 minus 1, A is the square matrix given by A is equals to 1 2 2 minus 1, it is the 2 by 2 square matrix. Then question number 1, verify Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem. Okay, the statement of Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. Okay, second one, find A inverse. Find inverse of square matrix A if exist. And the last question, find A cube. Okay, so a square matrix is given, we need to verify whether Cayley-Hamilton theorem verifies or not for the square matrix, and we need to find A inverse and also A cube. Okay, so let us start with characteristic equation. You need to consider characteristic equation. Characteristic equation formula is that A minus lambda I is equals to 0. Okay, here A is the given matrix, that is 1, 2, 2, minus 1, and lambda is the unknown. We need to take it as parameter, and I is the identity matrix of order 2 by 2, 1, 0, 0, 1 is equals to 0. It will be 1 minus lambda, 2 minus 0, 2, 2 minus 0, 2, minus 1 minus lambda is equals to 0. It is a 2 by 2 determinant. You can expand using the formula AD minus BC. Okay, so it will be minus of 1 minus lambda square minus 4 is equals to 0. Okay, it will be minus of 1 plus lambda square minus 2 lambda. It will be lambda square minus 5 is equals to 0. Okay, so we have taken characteristic equation formula that A minus lambda is equals to 0. Using the formula, the characteristic equation is lambda square minus 5 is equals to 0. Okay, so there are three parts in the question. So first part, verify Cayley-Hamilton theorem. Okay, so since lambda square minus 5 is equals to 0 is the characteristic equation, so in order to verify Cayley-Hamilton theorem, you need to verify A square minus 5i is equals to null matrix. Okay, lambda square minus 5 is equals to 0 is the characteristic equation. So in order to verify the Cayley-Hamilton theorem, you need to verify A square minus 5i is equals to null matrix. That is, when characteristic equation in place of lambda, if you replace A, the equation must be satisfied. Okay, first you need to compute A square. Okay, in order to find A square minus 5i, you need to compute A square. So A square can be calculated manually, or A square can be calculated using scientific calculator. Okay, first let us see the steps how to find A square using a calculator. Let us see how to find A square using a calculator. Okay, so first you need to, in calculator, you need to go to mode. Okay, in mode you need to press mode button until you reach mat. Okay, we are knowing how to calculate A square. How to calculate A square using a calculator. So the first step is take a scientific calculator and operate the button mode. Press mode several times so that you reach the option mat. Okay, under mat you have to select 2. Okay, take the scientific calculator and press mode button. Press mode button several times. Okay, then you select mat. So there will be a digit 2, you need to select 2, then mat will be selected. Okay, in the display you have mat. In the display you will have mat. Okay, then in the scientific calculator you press shift and 4. Okay, in the scientific calculator you press shift and 4. Okay, there will be 3 options such as dimension, edit and mat. Okay, so when you press shift and 4, there will be 3 options such as dimension, edit and mat. You select dim. Out of the 3 options you select dim. Okay, so by pressing 1, by typing 1, so you can select dim. Okay, again there will be 3 options A, B, C. Okay, under A, B, C you select A. Under ABC you select A. Then it asks row number and column number. Okay, then it asks row number as M. Okay, here matrix is of order 2 by 2, row number is 2. Okay, then you type 2 and press is equals to, then it asks N is the column number, here number of columns are 2, you type 2 and press is equals to. Okay, then it asks for mat A11. So mat A11 is element in first row and first column. Okay, here it is 1, you type 1 and press is equals to. Then it asks mat A12. Okay, here A12 means first row second column, first row second column element is 2, you type 2 and press is equals to. Okay, then it is asking for mat A21. It is asking for mat A21. Okay, it is element in second row and first column, it will be 2, type 2 and press is equals to. Okay, then we need mat A22. Okay, mat A22 is -1. Okay, so use a small minus, so enter -1 and then is equals to. Okay, so you entered all the elements into the matrix, the elements are 1, 2, 2, -1. Okay, so now we need to calculate A square. Okay, so we are learning how to find A square using scientific calculator. Okay, now again you press AC button. Okay, then again shift 4, AC button, shift 4, then you select, there will be 3 options, out of them you select mat. Okay, there will be 3 options, out of them you select mat, and in it you select matrix A, since we have stored all the elements into A previously. Okay, so in the display will be mat A. Display will be mat A. Now we need A square. A square will be mat A into mat A. You type into symbol, then shift 4, you type into symbol, then shift 4, then select mat, then select A. Okay, so now the display will be mat A into mat A. Okay, display will be mat A into mat A, then you press is equals to. Okay, so you will get the first element as 5. Okay, next element as, for the other elements you need to press right side of replay button. You got first element as 5, for the other elements you need to press right side of replay button. So then the other element is 0, the other element is 0, and the last element is 5. Okay, so now finally A square is 5005. Okay, so this is the procedure So once again, I will explain briefly. So A square we need, in order to verify Cayley-Hamilton theorem, you need to verify A square minus 5i is equals to null matrix. For that, you need to have A square. A square can be calculated manually or it can be calculated using scientific calculator. So using scientific calculator, let us know the procedure. So first you need to take a scientific calculator, then press mode button several times and you select the option mat. So in the display there will be mat will be displayed. Okay, then you select shift and 4, then you will have 3 options such as dim, edit, mat. Out of the 3 options you select dim. Okay, then you select matrix A, then it will ask for M. M means number of rows. Here number of rows is 2. Type the number and press is equals to, then it asks for N. N is number of columns. Type 2 is equals to, then it will asks for A11. A11 here is 1, then it asks for A12. A12 is 2. Type 2 and press is equals to, then it asks for A21. A21 is 2. Type 2 and press is equals to, then it asks for A22. Type -1 and press is equals to. Okay, now we have entered all the elements of matrix A into calculator. Now we need A square. A square in terms of calculator is mat A into mat A. Okay, once you press the AC button. Okay, then so we need to have A square. Here A square means mat A into mat A. For that, so select shift and 4, then select mat and select A. In the display you will have mat A, then you type into symbol or multiplication symbol. Okay, so then A square means mat A into mat A, then again shift 4 mat A. Now the display will be mat A into mat A. Now press is equals to. Okay, so you will get one element. The element is 5. So in order to get the other elements, you need to press right side of the replay button. So the remaining elements are 0, 0, 5. Enter the elements into the matrix accordingly. Okay, so this is the way to find the square of a given matrix using scientific calculator. Okay, so now consider LHS. It is A square minus 5i. Previously we calculated A square using scientific calculator. It will be 5005 minus 5 into I. I means identity matrix. It will be 1001. Okay, so subtract corresponding elements. It will be 5 minus 5, 0, 0, 0, 5 minus 5. It will be null matrix 0, 0, 0, 0. Okay, so hence we got A square minus 5i is equals to null matrix. Hence Cayley-Hamilton theorem is verified. So verifying Cayley-Hamilton theorem means you take the characteristic equation. Characteristic equation is lambda square minus 5 is equals to 0. Whenever you replace lambda with square matrix A, that equation must be satisfied. That is A square minus 5 is equals to null matrix. Since you can't add a number to a matrix, so you need to multiply number with identity matrix. Okay, that is A square minus 5i is equals to null matrix. So verifying Cayley-Hamilton theorem means whenever you substitute lambda with square matrix in the characteristic equation, the equation must be satisfied. That is A square minus 5 equals to null matrix. More meaningfully, A square minus 5i is equals to null matrix. Since we got A square minus 5i is equals to null matrix, hence Cayley-Hamilton theorem is verified. So Cayley-Hamilton theorem is verified here. Okay, for every square matrix it will be definitely verified. If it is not verified, means somewhere you got the calculation error. It will be in calculating characteristic equation. Suppose for some student, if the Cayley-Hamilton theorem is not verified, it means you got some mistake while calculating characteristic equation. So go back to characteristic equation and verify the determinant once again, so that this theorem will be verified. Okay, so our next question is finding A inverse if exist. Okay, now the second part is find A inverse. Okay, so we know that inverse of a matrix exists only if its determinant is not equals to 0. Here the determinant is -5 and it is not equals to 0. So there is a possibility of definitely the inverse of this matrix exists. Okay, so in order to find A inverse, let us start with the previous one. We have already verified A square minus 5i is equals to null matrix. Okay, so we have already verified A square minus 5i is equals to null matrix. Okay, so we got this from previous step, point number 1. So in order to find A inverse, multiply both sides with A inverse. To get A inverse, multiply both sides by A inverse. Okay, it will be A inverse into A square minus 5i is equals to A inverse into null matrix. Okay, take A square inside, it will be A minus 5 A inverse is equals to null matrix. Okay, so A square into A inverse, after simplification it will be A inverse into null matrix, it is null matrix. Now expression for A inverse is 1 by 5 into A, it is 1 by 5 into 1, 2, 2 minus 1. Okay, so it is the expression for A inverse. A inverse is equals to, it is the value for A inverse, it is 1 by 5 into 1, 2, 2 minus 1. Okay, okay. Next, there is a third part also. We need to find A cube. Okay, so A cube can be calculated manually also, or you can calculate it with the help of scientific calculator, but he is asking find A cube using Cayley-Hamilton theorem. Okay, so consider the previous step. You have already proved, consider the result in previous step. You have already proved A square minus 5i is equals to null matrix. Okay, now multiply both sides with A. So in order to get A inverse, multiply both sides with A inverse. In order to get A inverse, multiply both sides with A inverse. In order to get A cube, multiply both sides with A. So it will be A cube minus 5A is equals to null matrix A square into A cube, I into A, null matrix into A, it will be null matrix. So you need expression for A cube, it will be 5A. Now it is 5 into A is 1, 2, 2 minus 1. So it will be, you need to multiply each element of the matrix with scalar 5. It will be 5 into 1, 5 into 2, 5 into 2, 5 into minus 1. Okay, so when there is a scalar outside, you need to multiply every element of the matrix with the scalar. It will be 5, 10, 10 minus 5. So it is the value of A cube. Okay, so a square matrix is given. The first question we verified is, we have verified Cayley-Hamilton theorem, we have calculated inverse using Cayley-Hamilton theorem, we have calculated A cube using Cayley-Hamilton theorem. Okay.